Hey everybody, I'm Drew Hamilton with St. Paul College. I'm a customized training representative and I work for workforce training, continuing education here at the college. My area of specialization is everything trade and technical, and at St. Paul College we've got a lot of it. Today I'm going to introduce you to my buddy Garrett Byrne. He is our lead instructor for the CNC Machine Technology program.
Hey everybody, how's it going? I'm Garrett Byrne, CNC tool maker and tool and die maker here at St. Paul College. I've been here at the college for about 7 years. Here at the college we take someone that doesn't know much about machining, we turn them into a machinist so they can have an awesome career and have a good, well-paying job and a good skill set for the rest of their life.
So we'll take you all on a tour of the playground here today with Garrett. He'll take you through first, second, and third semester, show you what those semesters are comprised of. But we wanted to just talk a little bit about the industry and what exactly advanced manufacturing is.
Yeah, so advanced manufacturing or CNC manufacturing, basically what we're doing is we're going to take a raw piece of material and we're going to create a part, whether it's for the customer, for the public, for maybe a medical field, maybe it's parts for an airplane, parts for a vehicle. The nice thing about manufacturing, and especially in the CNC side of things, is everything that we use or we touch, a machinist made or had some part in making it. From the soles on your shoe to components for the car you ride in, buttons that you might press to open up your door, coming into a building, things like that. All the way down to if you've ever broken a bone in your body and had to maybe get a pin or some screws, a machinist is going to be the one that actually machines those parts. We like to say there's nothing we can't do, so if we can dream it up, there's a good chance we're going to be able to make it and manufacture it for our customer.
Just because I think this is cool, Garrett, do you have any, with your time in industry, do you have any pieces, parts, or components that you've produced that are on other planets?
Yep. So my first job out of college, I actually was fortunate enough to help manufacture the wheels or the rims for the actual Mars rover. So didn't know it at the time what we were making. It was just a blueprint. Turned out, ended up in space and on a different planet. So that was kind of cool to see happen.
You're interplanetary.
Yep.
So, Garrett, if you can, because we work with so many different organizations and different companies just with the CNC program here at the college, can you talk a little bit about industry? I know we have some great partners, some great industry partners on our advisory board. We're going to show you some of them today. But can you talk a little bit about some of the companies we work with?
Here at St. Paul College, we have a lot of great companies that love to hire our students.
Yeah.
Whether that's full-time when they've graduated or even part-time when they're going to school. Great thing about part-time is you're going to get more experience while you're in school, so you'll be in the shop with me all day. Then at night for 3-4 hours you're going to go into a shop. These are very well-paid part-time jobs. Majority of our students are going to start out around that $20 an hour range part-time. So if you can imagine yourself working 15-20 hours a week at $20 an hour part-time, it's a pretty good little paycheck. Plus you're going to get better because you're going to be working on the machines more. So your skill set's going to grow exponentially. Once our students graduate, they often end up in that $22 to $24 an hour range starting. And from there, the sky's the limit. The more you know, the more the pocketbook's going to grow. We've got a couple of companies that we like to work with. Graco, they do a great job. They have a wonderful internship program that a lot of our students go through with them, and also Vistatech. So hang on tight. We've got a couple of shop tours that are going to be popping up right now.
While you watch these videos, keep your eyes open, take a look at what you see. If you watch carefully, as you go on these videos with our industry partners, you'll see some of the specific equipment that we use that you would be training on here at the college before you get to industry. So take a look.
I think any student who is really have a strong desire to have a life that is filled with opportunity and wanting to have a comfortable life for a family and be able to contribute to the community is right for this job.
What if you knew that this ideal job could be a reality and that it wouldn't involve a 4-year degree or excessive student debt?
It's a 2-year program that you can go through fairly quickly, and when you get to the other end, you will have a living wage job that you can build on for the rest of your career.
In this industry, hard work pays off.
I like being a machinist because it's challenging. I think the problem solving and troubleshooting, things like that, is something that you learn every day.
Graco is a prime example of how professional machinists can work their way up. In fact, the CEO of Graco started his career as a machinist. Typically, the starting wage for a machinist is more than $20 per hour, and within a few years, machinists can make over $30 per hour.
I'm making a lot more right now than I would have retired with as a biology technician, so it was just the right choice.
I think I'm doing great, honestly. I mean, to be my age and, you know, have my peers make considerably less money than I do right now, I think I chose the right path.
Graco is committed to providing high job stability and benefits. Machinists are in high demand, and Graco is constantly on the lookout for qualified machinists.
I expect the demand for machinists to continue to rise. With the new technology that's coming out, with the robotics becoming really more commonplace, we really need high-skilled people to run that equipment.
Machine tool jobs, not only are they high-paying jobs, they're also jobs that are part of what's going to become our sustainable economy.
Don't settle for the same career path as everyone else. Find the path that is right for you. So how do you start your career as a machinist? Talk to your guidance counselor at school to learn more, or explore options through a technical college in your area.
It's always something new. It can be something new if you want it to be every single day. So I think that gets me excited to come to work.
There is no better time to start your career.
VistaTech, redefining manufacturing. Our philosophy of manufacturing is driven by VistaTech's people and processes. We have a deep heritage spanning 3 generations. VistaTech is not a traditional manufacturing culture. We provide equal opportunity work environments and encourage employees to leave their fingerprints on our processes, helping to shape and define not just best practices, but future practices. Our proprietary processes are designed to meet a wide variety of customer requirements. Instatech delivers fast, cost-competitive, simple parts. BridgeTech delivers more complex parts at low to mid-volume with the luxury of one vendor managing your program. Hitech delivers it all. High-volume programs from concept to completion with the speed and service on which VistaTech has built its reputation. VistaTech provides 360-degree in-house manufacturing. We assist in product development, create molds, perform injection molding, as well as inspection, decoration, assembly, and packaging. Our unique scalability allows us to serve your precise requirements in one location, eliminating the need for multiple vendors. For more information, browse our website or call today. VistaTech. Redefining manufacturing.
Hey everyone, thanks again for joining us for a little tour and a deep dive into what we do here at St. Paul College. So, right over in here we've got our manual lathes. Now, typically on a manual lathe, we're going to be doing a round part. So we're going to take something round and we're going to turn it down, we're going to face it, and create a part that way. Follow me this way. Over here is where we have our manual mills. Typically on a manual mill, we're going to take something square and we're going to machine that part down to make what our blueprint is asked for. Now we can go over this way, over into our grinding room here. And in the grinding room, this is where we're going to take a part after we get done on the mill or the lathe, and we're going to grind it down. So that means we're going to take very light cuts with the grinding wheel, or very light grinds, to create a nice shiny finish on our part, and to also make sure that our part is square and true to itself. Now, over this way is our second semester lab, and that's where we start to get into the fun stuff, the CNC side of things. CNC stands for Computer Numeric Controlled. This is where we take everything on our blueprint and everything that we learned in our first semester, and now we translate it onto one of the Haas mills right here. Now, with this, we set up all of our tools. We program it ourselves, either using G&M code, which is all X and Y moves, or we also can use what we call Mastercam to design and also machine our part. So if you follow me around here, you can see we've got quite a few mills over on this side of the shop. We're very fortunate here to have a lot of equipment and also tooling for our students to use. Now, as we round the corner here, you'll see that we've got the first of our CNC lathes. This is just like the manual lathe, however, just like the CNC mill. We're going to be able to program this, and it's going to be able to complete our parts for us. So, keep going around here. We've got another row over here of bridge parts. This is where we typically roughen our parts to make sure that they're ready to get machined. We also have our manual lathes as well over here. We've got a few drill presses over here as well. So there's more of our manual lathes. Come on in through this door here and I'll show you the inspection room. Now, in this room, you're going to see items such as the CMM. It's our coordinate measuring machine. We also have our optical comparator. Cool thing about the computer, or the machine over here, this little tip right here, it's a synthetic ruby. This is going to give us accuracies into the millionths for when we're measuring our parts. Just simply gets locked back into place, like so. Come on over this way and we'll go check out our third semester shop. So, over here in our third semester shop, our first stop's going to be into our automatic grinder room. Now, we went through the first semester side of shop. Those machines only move when we move them. So, we'd have to move our hands side to side and be coming in and out like so. With this machine, we're lucky to set our coordinates, set our parameters, how much we want to go down and take off. Hit this little green button right here, and this machine is going to automatically run for us. Now, first thing you'll notice as we come over back into the lab is the row of wire EDMs. So, wire EDMs are a very critical, very cool part of what we do. Take a thin brass wire and we create an electrical charge. Now the wire never actually touches our part, but it's able to cut out anything we want it to, as long as we can put a charge to it. This is aluminum. This project right here, we're making guitars. We're also able to take our wire, you'll see the Mitsubishi symbol right here, but we can also bend it, and on the back side, you'll see it says EDM. So we can offset our two heads, and we can cut and create tapers and things like that.
Garrett, when you put that in the machine, what does it sit in?
So right here, this is our wire EDM table. We've got our rails on the side. That's where we're going to clamp our part down. So it looks something like this, and we'll be able to do the work. This is our upper head. This is our lower head. The wire is going to get fed through. It's going to get spat out in the back. Now when I close this door, this whole table is going to get submerged in fluid. So if we come in the way back here, you can see where all of our excess wire goes. Right outside the back of your machine, that's where all your wire ends up when we're done using it. So we end up with our scrap wire there. So over here is our plastic injection mold. Students in our third semester get to create 2 and sometimes 3 or 4 different plastic injection molds when they're done. Basically what we're doing is we're taking an A side of the mold, the B side of the mold, we're going to squish them together, we're going to inject plastic into it, It's going to open up, it's going to knock it out. We're going to end up left with a part similar to this, which is a T-stop. This is what cleans out and helps clean out our CNC mills and also our manual mills.
So with plastic injection molding, to Garrett's point, a lot of the things that you guys use every day, to give you an idea of what comes out of this, your iPhone case, your cell phone case, that's how that's produced, is the plastic injection mold machine. The bottom of your Jordans, your sneakers, that's plastic injection molding. So just so you guys can understand what comes out, pretty common. A lot of the times when Garrett's doing things here in the shop, just have examples to show people of common parts that he produces. I'll ask him to make me one just so I can kind of show it off. Here it is, speed handle set. Garrett will actually show you how this is used. Show him, Garrett.
Yeah, so this is a speed handle set that we made up for Drew. All of our students here at the college get a chance to make this. So this main aluminum base right here was drilled and milled from a solid piece of aluminum on the CNC mill. This brass handle here, we did that on these CNC lathes, so we've got some knurls, which is a raised edge that helps you grip onto it better. Think of it as a bunch of little sharp points, but not too sharp. And it's drilled and bored out and also counterbored. Now for this, we come over here to our vise that's attached to either our CNC mill or our manual mill. This example right here, we're going to be attached to our CNC mill. Now, this right here is a standard vise handle. It's heavy, it's clunky, it kind of gets in the way all the time. This is light, goes anywhere, you can set it on the shelf, no problem. So all this does is, we're going to slide it on the vise, go to the left, loosen it up. Now my part's free. Put a new part in, tighten it down, pull it off, and we're ready to hit the green button and machine our part. Some of our lathes. So over here in our third semester shop, we've got another row of 5 mini mills over here. We've also got another row of CNC lathes. So currently we have 7 CNC lathes, and we've got about 16 CNC mills. So a lot of equipment here. Students get a lot of seat time, better their skills, and end up becoming a better worker when they get out into the workforce.
Hey everybody, Drew Hamilton back again. Wanted to show you guys a little bit about the technology side of the CNC Advanced Manufacturing program here at St. Paul College. So I am in one of the CAD or CAM classrooms. We have 3 of them here at the college. If you're wondering what CAD or CAM is computer-aided drafting. CAM is computer-aided manufacturing. So for those of you who are wondering a little bit more about what the career field is made up of, we wanted to show you kind of some of the technology side of advanced manufacturing. So I'm going to have Garrett take you guys through and show you a little bit about what he can do and what you can do here in the labs at St. Paul College.
Hey everyone, just want to take a little time and talk about how we take our CAD drawings, which look like this. We end up drawing it on a computer, comes out right on a piece of paper. Now our job's not done. Once we get that done, we need to take this piece of paper, take our blueprint, and bring that into our CAM software, which is computer-aided manufacturing. And from there, we're going to toolpath the part. Now with that, our part is going to end up looking just like this. A couple different ways we can verify to make sure it works and make sure it runs. We can verify it on our CAM software, or we can come over here to our Haas simulators right here. This is going to give us the exact simulation of what our machine is going to do out in the shop. All we have to do is load up our program and simply press the cycle start button, and it's going to overlay the tool paths and show us how this part gets created, just to make sure we haven't made any mistakes.
Hey guys, thank you for being here. Thank you for experiencing this virtual tour with us. We were glad to have you. Hope you learned something. Hope you guys had some fun. Hopefully we opened your eyes to opportunities within the advanced manufacturing and CNC industries, and we hope to see you again soon.
Yeah, and also remember, if you've got any questions, comments, or would like to come check out the program at any time, please feel free to email myself or Andrew, and we'll get back to you as soon as possible. Thanks again.